In this video, we'll talk about how bones grow in terms of length. A subsequent video will talk about how they grow in width, but we're really going to focus in on how do they grow in length. Because it's no big secret that between the time we're born and we hit adulthood, we have gotten taller. So we have to have a way to make especially those long bones grow significantly. So long bones lengthen by longitudinal growth. So they're going to get longer this way. Now there is another process that happens in terms of width, and it makes sense because if all we did was make them long, they would be very skinny and very prone to breaking. But we're really going to focus in on the process that causes the bones to grow in length. Now there are special zones called the epiphyseal plate, and they are located in different areas. So in this case, you can see they're located between the epiphysis and the diaphysis, or the shaft, and it's known as the epiphyseal plate. Now, bone growth takes place at the epiphysis, which is what this is, the epiphysis, on the side closest to the diaphysis. That's the shaft, right? The epiphysis, epiphyseal plate, this is where the bone growth is going to occur, and this is the shaft, or the diaphysis. Now, what we're going to see is within the epiphyseal plate, we have hyaline cartilage that did not ossify during that initial endochondral ossification. And when I look within the epiphyseal plate, I'll see that there are 5 different zones of cells, one stacked on top of the other. And of course, we'll just refer to them the zone of. So we have the zone of reserve cartilage, and that's one on the epiphysis side, and we'll have a look at this. Now, these cells are not directly involved in bone growth, but look at the name, zone of reserve cartilage. The cells can be recruited for cell division if needed. Now, right above that zone, we enter another zone called the zone of proliferation. And this is where we actually have chondrocytes actively dividing. And if you remember from past discussions or past readings, the chondrocytes, here's a chondrocyte, they exist within a little chamber called a lacunae. So in this zone, we're going to have actively dividing chondrocytes in their lacunae. Now, above that, so we're now up to the third zone up, we have the zone of hypertrophy and maturation. Okay, and here we see we have mature chondrocytes. Above that, we have the zone of calcification. And here the chondrocytes are now dead, and we're starting to get a bit of calcification of the tissue. The zone of ossification. Now, by the time we reach here, we have calcified chondrocytes, and we're starting to see osteoblasts. Remember, osteoblasts are the true bone-making cells. Now, let's have a look at this. So we can see this is the diaphysis here. That's the shaft of the long bone, the epiphysis, and here is the epiphyseal plate. And what we're doing is the zones go in this direction, okay, from the reserve cartilage, etc. So we're going to take this little section through here and enlarge it over here. And when we do, we can see from the very bottom, okay, from the very bottom, we have the reserve cartilage. Above that, proliferation, zone of hypertrophy, zone of hypertrophy and maturation, zone of calcification, and the zone of ossification. And you can start to see how it looks different. That down here in the zone of reserve cartilage, it's your typical what you'd expect seeing cartilage. You have chondrocytes that are within their lacunae, and then you have the extracellular matrix. So above the zone of reserve cartilage is the zone of proliferation. Remember, these can be called on for cells for mitosis if need be. The zone of proliferation is really where I'm getting a lot of the cell division of the chondrocytes, individual chondrocytes within their lacunae. Right? And then as I move, so you can see chondrocytes in their lacunae. As we move up, we get into the zone of hypertrophy and maturation. Now, you can see that we're starting to see some differences as I'm starting to move from the zone of hypertrophy and maturation to the calcification. You can see that in general, the lacunae are getting bigger. I'm starting to have hypertrophy here happening up here. So this is the zone of hypertrophy and maturation. And then I have the zone of calcification. So I'm starting to get calcification of the matrix. It's not bone yet, but it's starting to calcify. And then the bone of ossification. Now here, the osteoblasts are starting to invade, and now they're starting to structure real bone. So, as I said, tissue is made, more tissue is made here. It pushes up the older tissue. The older tissue moves along. It enters a different zone. It changes its morphology, its function. And so I can go from basically having cartilage that gets transformed eventually into real bone. And this is the process of how we make the bone longer. And you can actually see it here. And this is the artist diagram. You can see it here in the actual histological section. Chondrocytes and their lacunae, the matrix, the zone of proliferation, the zone of hypertrophy. You can see how those lacunae are starting to get bigger, especially as I get near the superficial or the top end of the epiphyseal plate. The chondrocytes are dead here. I've had some calcification of the tissue, and then the osteoblasts come in. And yes, there is calcified cartilage, but the osteoblasts will eventually turn this into real bone structure. And so I'm adding new bone material here, which then makes the shaft even longer, and the bone gets taller as a result. So, as I said, each zone of the epiphyseal plate, except for the reserved cartilage, is actively involved in longitudinal growth. The chondrocytes in the zone of proliferation, they divide, they force the cells ahead of them into the next zone, up in sort of the diaphysis area. The chondrocytes reach the zone of hypertrophy, they enlarge, they stop dividing, the lacunae are larger. The chondrocytes reach the zone of calcification. We start to have the chondrocytes die off. They're very far from the blood supply, and the matrix calcified. And then when I get into the zone of ossification, the calcified cartilage is replaced by bone. And of course, osteoblasts invade the calcified cartilage, and they lay real bone down on top of it. Now, what happens is eventually the calcified cartilage and the primary bone are reabsorbed by the osteoclasts and eventually replaced by mature bone as a result. Now, this continues. It doesn't continue for your whole life, as the epiphyseal plate exists as long as the mitosis continues in the zone of proliferation. But this mitotic division starts to slow down sometime in the ages of 12 to 15, but ossification will continue. Eventually, the thickness of the epiphyseal plate shrinks because the zone of proliferation is overtaken by the zone of calcification and ossification. And sometime around the ages of 18 to 21, the zone of proliferation has now been completely ossified. So there's no more chondrocytes to add more matrix and material to allow for elongation of the bone. So elongation stops and the epiphyseal plate is closed. Now there is a remnant that what was the epiphyseal plate has now been calcified, and we call it the epiphyseal line at this point. And once again, we can just see an overview here, is that the zone of proliferation, I have dividing chondrocytes. I have the matrix in the extracellular matrix. As I move into the zone of hypertrophy and maturation, I have elongated chondrocytes and larger lacunae. And then the material moves up. So here they've enlarged, they've matured. When they hit the zone of calcification, the chondrocytes die and the matrix calcified. So I'm starting to get calcium salts within the matrix. As I move up to the zone of ossification, the calcified cartilage gets replaced by bone, and eventually I end up with a newly formed bone. Now this bone can be remodeled over time because remember, in bone you have stress lines, you have a certain architecture of compact versus spongy bone. So that will be modified over time. But all this has allowed me to add new material onto the diaphysis, which means overall the bone gets longer as a result. All right, so that's a quick overview. Make sure you go back, look at your book. There's some good videos that are posted on the website that will also walk through this.